two matrices are equal, if they have the same dimensions, and corresponding entries are equal. If A and B are equal, then we could say that for every I and for every j, the entry in the ith column of A, or if A and B are equal, then for every I and j, if A and B are equal, then for every I and j, if A and B are equal, then the element in the ith row and jth column of A will always be equal to the element in the ith row and jth column of B for all rows I and columns j. Let's do an example that requires an understanding of matrix equality. Here, A is a 2 by 2 matrix with elements 5x, negative z, 3x plus y, and just y. And B is the matrix 5, 7, 10, 7. If we are told that A equals B, then we can solve for x, y, and z. Because A and B are equal, we know a variety of things. We know that 5x equals 5, negative z equals 7, 3x plus y equals 10, and y equals 7. This again comes from the fact that corresponding entries are equal. From this knowledge, we might be able to find that x equals 1, y equals 7, and that z equals negative 7. Addition and subtraction. If two matrices have the same dimensions, then adding or subtracting matrices is done by adding or subtracting corresponding entries. Symbolically, we can say that the element in the ith and jth row of A plus B is the element in the ijth row column of A plus the element in the ith row jth column of B. Matrix 5, 6, 10, 1 plus 1, 1, 2, 3 becomes 5 plus 1, 6 plus 1, 10 plus 2, and 1 plus 4. Subtraction follows in a similar method. Scalar multiplication. We can multiply a matrix by a number. This scales every entry of the matrix. Our example of this will be if our matrix was 10, 12, 13, negative 1, and we multiplied it by 5, you'd multiply every entry by 5. The transpose of a matrix, which we signify by adding a little t as a superscript, is a matrix where the rows of M transpose are the columns of M, or vice versa. Our example of this, we can define M to be the matrix, to be the 3 by 2 matrix, 2, 3, 1, 4, 0, negative 1. M transpose will have dimensions that are swapped. So if the dimensions of M is a 3 by 2, the dimensions of M transpose will be a 2 by 3. The first row of M transpose will be the first column of M. The first column of M is 2, 1, 0. So our first row in M transpose will be 2, 1, 0. And similar, second row will be the second column of M. We could also choose to interpret this as saying the first column of M transpose is the first row of M. So here the first row of M is 2, 3, and the first column of M transpose is also 2, 3. Here we'll note two things. How transpose distributes through parentheses, and how the transpose of a transpose is the original matrix. If a matrix is equal to its transpose, then we say that it is a symmetric matrix. Here the matrix A equals 2, 3, 3, negative 1, the 2 by 2 matrix, is symmetric because the transpose of A is again 2, 3, 3, negative 1, which is what we started with.